Welcome to another insightful video. I'm Ryan Chan, CEO and founder of UpKeep. Today, we will be delving into the world of acoustic analysis, an incredibly effective yet underutilized tool in predictive maintenance. We'll be exploring its two key components, sonic and ultrasonic analysis, and revealing how these techniques can supercharge your maintenance and operations teams. You'll learn how to identify issues before they become problems and how to train your technicians more effectively. So, let's get started. Acoustic analysis may not be as widely used as predictive maintenance tools like infrared and vibration analysis, but it certainly packs a punch when it comes to effectiveness. Why, you ask? Well, that's because it has two different and equally useful parts. First up, we have lubrication analysis, also known as sonic analysis. This technique uses microphones that pick up sounds within the human audible range. While sonic analysis may not be as versatile as ultrasonic analysis, it's a fantastic tool for lubrication analysis. Imagine this. You're listening to the moving parts of an asset using sonic microphones. You identify areas that aren't properly lubricated. What do? You fix them using the right lubricants, of course. But that's not all. Sonic analysis also plays a key role in lubrication training. Facilities can pinpoint areas that are consistently under or over lubricated and train technicians accordingly. But what happens when a facility has a massive number of assets or an asset made up of a multitude of different moving parts? That's when sonic analysis starts to lose its edge due to the sheer amount of noise. Enter ultrasonic analysis. This technique becomes a handy way of testing stress and motor function in complicated assets because it listens to sounds in the non-audible spectrum. Consider a hydropower power station, for instance, which has a large number of moving parts. Ultrasonic microphones, with the help of machine learning, can be trained to listen for a specific sound that indicates failure. Once that sound is detected, a work order is automatically submitted. Now, let's talk about diagnosing hidden machine stress. Some motors or moving parts might make a loud sound when they stop working, but that's a reactive maintenance scenario. It means that the motor had to completely break before the maintenance team knew it needed to be fixed. That's where ultrasonic analysis comes in. A facility can diagnose the stress on a motor by listening to changes in its frequency and highlighting abnormal sound patterns. These patterns indicate that the motor is wearing down. This way, maintenance can be planned in advance to minimize downtime. So while acoustic analysis might not have as many applications as some other predictive maintenance tools, it more than makes up for it with its effectiveness in diagnosing and preventing potential issues. Thank you for watching. Today, we've explored the power of acoustic analysis in predictive maintenance, delving into sonic and ultrasonic analysis, and how they can enhance your maintenance and operations teams. If you found this information valuable, please subscribe to our channel for more insights. For more information about our tools and resources, visit us at upkeep.com. We look forward to helping you optimize your maintenance and operations.